All right, this is section 1.2, part 2. The I can statement again is I can multiply and divide integers. Again, don't forget what integers are. Got to be able to explain that, have that definition memorized. So here's our warm-up today, and you want to make sure that you're prepared to answer these out loud with the class, maybe talk with a neighbor about them or something like that. If you need to use a number line, you're welcome to. So let's stop and think about that. What is the opposite of owing $5? Well, let's think about this for just a second. You owe $5. The opposite of that, we talked about this yesterday, would be having $5. But then if you have $5 and you do the opposite of again, then you would still owe $5. It's almost like these two opposites, they kind of cancel each other out and we still owe the $5. And then it says, what is the opposite of 7? So let's kind of work backwards here. The opposite of 7 would be -7, okay? But then we want to do the opposite of that. So the opposite of -7, we would be back to +7. And again, it's kind of like the opposite of the opposite kind of cancel each other out. And we can do the same thing on this one. Again, let's work backwards. We start with -10, and if we do the opposite of that, we'd have +10. And if we do the opposite of +10, we'd be right back at -10. Okay, so that's kind of how those work. And then I always like to do just a quick reminder of some of the procedures and things that make our class run well. And one of them, I think one of the most important ones, is what listening means in our class. It means two things, and hopefully you can remember what those are. Those two things are, first of all, you're sitting quietly. And then the second is you're looking at the teacher. Or whoever might be in charge that day. Maybe somebody's up explaining a problem at the board and they need your attention. They might say listen up or hey class or whatever it is. So you need to be sitting quietly and then looking at the teacher, whoever's in charge. Okay, so let's talk more about multiplying and dividing integers. If we say numbers always start out to be positive, remember we started out learning counting numbers when we were in elementary school or even before then. Is there a limit to how many times we can use a negative to change the direction of a number? Remember, the word negative means opposite. So is there a limit to how many times we could switch back and forth, kind of like we were doing here? These got a little bit crazy in here. But let's try a couple problems and let's see if we can kind of find a pattern to this. And remember implied multiplication. Each one of these has implied multiplication in it. There's no symbol in between these. There's no add, subtract, multiply, or divide symbol or anything like that. But remember, when there's nothing in between, it means multiplication. So we've got a +4 times a +6. So positive times positive is going to be positive. And 4 times 6 is 24. So the answer on that one's 24. We've got a negative times a positive, so that's going to be negative, and 7 times 3 is 21. Okay, so the answer on that one's -21. This one's a little bit longer, so let's run through here. We've got a negative times a positive, so if we just multiply the two of these together, we multiply them together and we get -2, and then we're going to multiply that by -5. Negative times a negative is going to end up being positive, and 2 times 5 is going to be 10. So if we look at that really carefully, let's just double check. Negative times a positive is negative. 2 times 1 is 2. Yep, we got that part right. And then we multiply it by -5. Negative times a negative is a positive. 2 times 5 is 10. Yep, we got that one right there. We'll do the same thing with this one. Luckily, we've got the same numbers, just different signs here. So if we multiply these two together, negative times a negative is a positive, and 1 times 2 is 2. Okay, and then we multiply that by -5. So positive times a negative, we end up with a -10 on that one. And then we've got, oh, look at this sitting out in front here. This is just a plain old negative, and we've kind of dealt with that before. I guess we could kind of think of that as an implied -1 there. But if we've got a negative times a negative, this is going to be a +3 times a -2. And I'll just do this a piece at a time. We've got a positive times a negative, that's going to be a negative, and 3 times 2 is going to be 6, and then we're going to multiply that by -10. So we've got a negative times a negative, that's going to be a positive, and we end up with 60. So we end up with a +60 for the answer. So here's what we really want to look at. We want to look at this and we want to figure out, is there a pattern to this? So let's take a look here. Let's see, we've got a positive here, we've got a negative here, a positive here, a negative here, and then a positive. And we didn't have any negatives here, and we had all negatives here. But here's another one with all negatives. So let's see, let's do this. Let's write down the number of negatives. Well, how many negatives are part of this multiplication problem? There are 0. Okay, and the answer turned out to be positive. How many negatives are part of this multiplication problem? Well, there's 1, and it turns out to be negative. In this one, there are 2 negatives, and the answer turns out to be positive. Let's count them here, 1, 2, 3. So there are 3 negatives, and the answer turns out to be negative. Let's see, count them up here, 1, 2, 3, 4. 4 negatives, and the answer turned out to be positive. So could we come up with a rule where we could look at it, and again, this is kind of compartmentalizing. The number answer is pretty easy to find. We're just multiplying the numbers together. The question here is, what's the sign of the answer? Is the answer going to be positive 24 or negative 24? Positive 21 or negative 21? Negative 10 or positive 10? Same thing on each one of these other ones. So hopefully you can look at that and you can see that there's a pattern here. Well, any of these that are even, so I'm going to highlight the even ones. If there's an even number of negatives, look what happened to the answer. It turned out to be positive. And if there's an odd number, like 1 or 3, the answer turned out to be negative. So we could make up a few problems to kind of test and see if our rule works. But let's just run through and let's see what we've got here. We've got 1, 2, 3 negatives. So according to our rule, the answer should turn out to be negative. And if we multiply, well, the numbers here, that would be kind of like an understood 1 right there. So this is a 1 times 33, so the answer should be negative 33. Well, let's check and see if this works by going through and doing it piece by piece. The opposite of negative 1 would be positive 1. And if we times that by negative 33, positive times a negative is a negative, so it does end up being negative 33. I'm going to make that look just a little bit better. So that is the right answer. Let's try it out on this one. We've got a negative here and a negative here, so we've got 2 negatives. 2 negatives would be like this one right here, so we think the answer is going to turn out to be positive. I'm going to put a plus there just to remind us. And then 5 times 14, that's not part of our multiplication tables, but we can figure that out. 5 times 10 is 50, and then 5 times 4 is 20, so 50 plus 20 is 70. So we think the answer is positive 70. Well, let's double check. Negative times a negative is a positive, and 5 times 5 times 14 is 70. So this is the right answer. So far that's working well. Let's take a look at this one. 1, 2, 3 negatives. 3 negatives would be like that one right there. The answer should be negative. And if we multiply the numbers together, we get, let's see, 2 times 4 is 8. And then 8 times 5. 8 times 5. 8 times 5 is 40. So the answer on this one should be negative 40. Well, let's double check and make sure. Multiply these two together. Negative times a negative is a positive. That's going to be a positive 8. And then we multiply that by negative 5. Positive 8 times negative 5. Positive times negative is negative. 8 times 5 is 40, so we got that one right. And let's take a look at this one. Usually we won't have problems this long, but let's see. We've got some implied multiplication here. We've got the little dot that means multiplication. Let's check and see. 1, 2, 3, 4 negatives. That's like this one up here, so the answer should be positive, like we got positive 60 right here. So let's see, we've got 2 times 10 is 20. 2 times 10 is 20 times 1. 20 times 1 would be 20. And then 20 times 3 would be 60. So the answer on this one happens to be 60. Okay? And if you'll notice, this is just kind of a rearrangement of this problem right up here. So the answer is going to be the same, and I'm going to do this one other way just to kind of verify. We've got a negative times a negative is a positive, so that's going to be a positive 20. We've got a negative times a negative is a positive, so if we multiply those together we get a positive 3, and then 20 times 3 is definitely 60, so we got that right. And again, we're practicing all of these without a calculator, so make sure you're not using a calculator. So Let's do a couple of these just as practice. So we've got a negative divided by a negative. Negative divided by a negative is positive. We'll tell you what, let's come down here and let's make sure we're clear on how this works. What we're going to do is we're going to count the number of negatives in the multiplication or division problem. If the number is even, the answer is going to be positive. And if the number is odd, the answer is going to be negative. We'll talk about why that works, or maybe you can think about why that works in just a second. So let's see, negative times a negative, we've got two negatives, so the answer is going to be positive because that's an even number. And then we've got 36 divided by 3. 36 divided by 3, the answer is going to be 12. We've got two negatives right here, so the answer is going to be positive because that's an even number of negatives. And so we're going to do 3 times 7 is 21. We've only got one negative in the problem, and that's odd, so the answer is going to be negative. And 45 divided by 3 is going to be 15, so negative 15 is the answer there. Take a look here, a little bit longer problem. 1, 2, 3 negatives. 3 is an odd number, so the answer is going to be negative. We've got 3 times 2 is 6, and then 6 times 8 is going to be 48. So the answer is going to be negative 48 on that one. I've got an asterisk by this one right here because this one's kind of interesting. Let's use our rule and let's see if we get this right. 1, 2, 3 negatives. So we're thinking the answer should be negative. And let's see, on the bottom we've got parentheses here, so let's do what's in parentheses first. This is a negative times a negative, that's going to be a positive 5, and the top is going to be a negative 15. And we've got a negative divided by a positive, answer is going to be a negative. 15 divided by 5 is going to be 3. So look, it does turn out to be a negative answer right there. One negative, so the answer is going to be negative because that's an odd number. We multiply these together. Let's see, 20 times 4. 20 times 4 would be 80. So 21 times 4, let's see, that would be 80 plus 4, so that's going to be 84. So negative 84 is the answer on that one. A couple more difficult problems here, and again, you should be able to do these without a calculator. If we need to use some long division or something like that, then we'll go ahead and do that. Negative divided by negative, okay, two negatives, that's going to make a positive, and 105 divided by 15. So if you needed to, there's no problem making a division box and then doing something like this. Trouble is 15 doesn't go into 10, so we've got to just flat figure this out from scratch. If we did 6, that would be 30, carry a 3, so that would be only 90. We'd have 15 left over, so the answer on this one's going to be 7. Because if we do 7 times 5, that's 35, carry a 3. 1 times 7 plus 3, there's our 105. So it goes in 7 times. So the answer, negative divided by negative, is positive. So we end up with a positive 7. Negative divided by a negative is positive. We've got those two negatives. Two negatives would make a positive. That's an even number. And then 66 divided by 22. So think about that for just a second. 66 divided by 22. Answer on that one's going to be positive 3. So if you stop and think about why this works the way it does, why you can just count the number of negatives, goes back to what we talked about earlier. If we assume that every number started out to be positive, like those counting numbers that we learned to count with at the very beginning, even before elementary school, if we assume everything starts out to be positive, the only thing that's going to change its direction and make it negative is that negative sign. And if we change it, if we don't change it at all, or change it in an even number, it's going to flip from positive to negative and back. And if it's odd, like 1 is going to flip it from being positive over here, it's going to flip over here and it's going to make it negative. If we do it 3 times, we'd go 1 negative, 2 negatives, 3 negatives, so we'd flip back here, so it would be negative. If we did 5 negatives, 1 negative, 2 negatives, 3 negatives, 4 negatives, 5 negatives. It's just a question of flipping it back and forth. And again, like we said just a second ago, if it was an even number of negatives, so 1 negative, 2 negatives, flips it back to positive. 1 negative, 2 negatives, 3 negatives, 4 negatives, flips it back to positive. So it's all about direction. Okay, so this works because we're talking about the direction that a number is, and that a negative will do the opposite direction. So hopefully that makes sense. As we're doing things in class, we can go over more questions and make sure everybody's clear on this. All right, thanks. You can go ahead and get started on the second part of the homework.